Hi again, everyone. Welcome back to our course in college algebra. Dr. Tom McNamara here. We're going to talk today about solving rational equations. And when I say a rational equation, I mean an equation that involves fractions. Now, typically, these rational equations that we'll be dealing with in our class will involve fractions in the denominator. And we're going to make use of a technique called clearing denominators. It's going to be a very useful tool for solving these rational equations. We have actually used this technique of clearing denominators before, so let's do a quick review. This is a linear equation. The x here is not part of the denominator. It's 3/4 times x minus 1 equals 7/5. So we're supposed to find the value of x that makes this a true statement. Okay, so I look at my denominators, I see I have one denominator of 4, a second denominator of 5, my LCD is 20. And when you're constructing your LCD, remember you are creating a number that all of your denominators divide into evenly. So 4 divides into 20 evenly, and so does 5. So that's our LCD. And what we're going to do is we're going to multiply all the terms in our equation by 20. Okay, and of course, if I do something to one side of the equation, I'm supposed to do that same exact thing to the other side. So if both of these guys get multiplied by 20, and this gets multiplied by 20, then I am keeping the equation equivalent to what I started with. Okay, now what's the point? Well, the point is this 20 has a factor of 4 living inside. So that factor of 4 living inside the 20 will cancel the 4 in the denominator, leaving me with a 5. Okay, so that first term becomes 15x. That's a 20, and this is a 28. Okay? Because 4 times 7 is 28. And now we go ahead and we solve this new equation for x, getting x equals 48 over 15. Okay, this equation, very easy to solve. You want to get x by itself on one side. Get rid of that 20, add the 20 over. Divide by 15. X is by itself, x equals 48 over 15. Okay, so very useful technique here of clearing denominators. So the strategy involves finding the LCD and then multiplying both sides of the equation by that LCD, and the point being that since you're using the LCD, all the denominators divide into that LCD evenly, so it will cancel out all your denominators, giving you a new equation, a new equivalent equation that does not have fractions anymore. So let's look at a few bona fide rational equations. And by that I mean a rational equation that has variables in the denominator. Okay, we'll do 2 easy ones, and then in the next video we'll do 2 more involved ones. Okay, let's try and solve each of these. Let's do 1/3 minus 5/6 equals 1 over x. Okay, so this is a rational equation. We have a variable in the denominator. And when you have stuff like this, there's really no other way to solve it. That previous example, I could have just done the arithmetic with fractions. I didn't really need to use clearing denominators to solve it. But here, there's really no other way to do it. Well, I guess there is, but it's going to be easier if we clear denominators. Okay, so my LCD is 6x. 3 divides into the 6 divides into the 6, and the x divides into the x. Okay, 3 has to divide into my LCD evenly, 6 has to divide in evenly, and x has to divide in evenly, so that's why I need that x there. We multiply every term by 6x. The 1/3 gets multiplied by 6x. The 5/6 gets multiplied by 6x. And the 1/x gets multiplied by 6x. Let's look at what happens over here first. X is canceled. We are left with a 6. Over here, 6 is canceled. Minus 5x. Over here, the 6 cancels with the 3, leaving a factor of 2. So 2x. All right, over here we can combine like terms. 2x minus 5x is negative 3x. If negative 3x equals 6, that must mean x is negative 2. Okay, so when you have an equation, you're basically presented with a problem. Now this problem is actually made more difficult by the fact that we have fractions. And the technique of clearing denominators gives us a new equation that doesn't have fractions anymore. So we are eliminating that obstacle to solving the problem by getting this new equation over here. Okay, we'll do one more example. And in a follow-up video, we'll do some more involved examples. So 1/2 plus 1/x equals 1/3 plus 3/x. Okay, so once again, looking at my LCD, I need a number that 2 divides into evenly, that 3 divides into evenly, and that x divides into evenly. So actually, once again, I'm going to use 6x as my LCD. As we'll see in the next video, you don't always use 6x as your LCD. It just kind of happened that way. All right, so every single term times 6x. So the 1/2 gets hit with a 6x. The 1/x gets hit with a 6x. The 1/3 gets hit with a 6x. And the 3/x gets hit with a 6x. Some cancellations. Remember, you should be getting lots of cancellations. The whole point of multiplying both sides by the LCD is so that the denominators get canceled out. Right? That's the whole point. We want a new equation that does not involve fractions anymore. Okay, so here the x's cancel. Here a factor of 3 cancels, leaving me with a factor of 2. Let's look at what this becomes. This becomes a 3x plus 6 equals 2x plus 6. Is this right? Let me see. So my x is canceled, so I'm left with a 6 there. Oh, okay, interesting little thing happening right here. This is an 18. Okay, I was not expecting to get x equals 0 there. So the thing I messed up was I said this was a 6, right? But there's a 6 and there's a 3. Okay, that should have been 3 times 6. So then when we do this, we get x equals 12 as our solution. We could, of course, go back up to the original equation and check, but so key thing here, right? The factors of x canceled. The 6 is still here. The 3 is still here. That's why that had to be an 18. Okay. So here we get x equals 12. So once again, using the LCD gives us a equivalent equation that doesn't have fractions anymore. And when I say equivalent equation, I just mean an equation that has the same solution set. The solution to this is x equals 12, and since we got this equation by doing a valid algebraic operation to this equation, they have the same solution set. Okay? So, in your exercises, I'm going to assign plenty of practice problems to work with clearing denominators. And on our next test, that's coming up in the middle of the semester, we will be dealing with rational equations on that test. So make sure you get that practice in so that you're good to go.